Howdy again, it's Mr. Pete, and I thank you for watching my videos, and I'm glad you're watching this one. And I enjoy doing them, so continue watching if you would. Now this is tips number 519, and it's all about making Jacob's wedges. Now in recent videos I showed you how to remove chucks using Jacob's wedges, and I showed you or talked all about the different kinds of wedges and the different sizes and that. But in this one I need a very small set of wedges that weren't available, so I'm going to make them, and you can follow me through this process if you need to do something like that. But even if you never do, you might find it interesting. So let's get started with it. Watch tips 448, which is called What is a Jacob's Taper, and 449 is entitled Removing an Albrecht Chuck using Jacob's Wedges. So, and I've talked about this before, so it's just a little bit of a review. But Jacob's offers 3 different sizes of wedges, actually 4. I have 3 of the different sizes, the number 1, 2, and 3. But if you look in their catalog or their website here, you're going to see that they also sell a number 6 wedge set, which is the largest of the 4, but they do not sell the little number, well, we would call it 0, but they don't apparently make it, but it would be for the 0 Jacob's taper. The number 1 will only handle a number 1 Jacob's taper. The 0 is very small. So I have made a set of those and used them in the other video. These are homemade, and since I really don't need another one, I'm going to make just one of them to show you how I did this, and it's actually a fairly easy job. Follow me on Instagram if you do not already do so. For comparison here, this is a number 1 Jacob's taper. This is the number 0, so you can see there is considerable difference. This is only about 1/4 inch in diameter, and I have that size on my little micro drill press, the Cameron. You've all seen my videos on that. And that's what inspired me to do this, I guess. Well, not I guess, I know. So the number 2, or the number 1 back, getting back to that, the number 1 you can see fits on this size. And the one that I'm going to make will fit on this. Get in there. Like that. And here's an example. This is a portion of a chuck. Of an Albrecht chuck. That's what I removed in the other video, but that'll fit right on like that. And you need this size in order to remove them. Now there are going to be some people, I know, Primitive Pete and Bubba are going to use a chisel, because after all a chisel's a wedge, or they're going to use a screwdriver. But don't be a Primitive Pete. Do it the right way. These are only about $15 for a pair of them, so they're not terribly expensive, but when you couple that with shipping and all that and the time that it takes to get them, you know, it's just a nuisance. But the genuine Jacobs like this are made of hardened steel. They're high quality. So I am going to make this set out of tool steel. This is a piece of precision ground tool steel, marked as such. It's 1/8 inch thick and it's 1 inch wide, a little wider than what I need, but really it's just perfect, and I had this in stock. So this is tool steel. It is very tough. I found that I didn't need to harden it, but I could go back and harden them if I desired, because it is tool steel. So, but it just really wasn't necessary. But if you're making the larger sizes, you probably will have to harden them, because those big arbors do not come off the chucks all that easily. What is the angle of this wedge? Anybody want to take a guess? It's not much of a taper, and it's pretty gradual. Well, we got to measure it. And this particular type of protractor to me is not all that handy to make that kind of measurement on a real minor taper like this. So I got out the Starrett, and again, this isn't all that easy. So I'm showing you several different ways, but laying it on there and getting it parallel and all of that, I came up with about a 3-degree taper. Now it doesn't have to be exact, so I'm going to call it 3 degrees, but let me show you another way. Okay, here's an alternate method. You remember that recently Michael Bucciaroni gave me this wonderful little die maker square, and it will measure minor, small degrees, so I'm going to go ahead and set that up here using a 1, 2, 3 block as a square to hold the wedge, and I will use this. Let me get the camera into a little bit better angle so you can see how nicely that works. With the wedge setting up against the 1, 2, 3 block, and the wedges do not set real flat. There's a bit of a warp to them, but using the little die maker square here and just getting it parallel or as close as possible, you can see that I'm also coming up with about 3 degrees. Isn't that a little beauty? All right, one more method. These are angle blocks. I call them taper gauges, but actually that's not correct. That's just my own internal notation here. And I've already done this off camera, but let's see, what is that? That's the 3-degree one. That's the one I'm going to use here, and by trial and error I also determined that this is 3 degrees. I know I'm belaboring this. Let me show you. These are 1/4-inch lathe tool bits. I'm only using them as parallels. Laying the Jacob's wedge on there, and this is the 3 degrees. I'm bringing that up, and I don't know if you can tell real well, but it's pretty darn parallel. The wedge is pretty darn parallel, certainly close enough to the 3 degrees. So by these different methods here, I'm showing you that it's a 3 degrees. I spent too much time on this. You could use a sine bar, just all other different kinds of ways, but that's how I did it. 3 degrees. Now that I have determined that it's 3 degrees, how am I going to hold the work in the milling machine? As most of you already know, I would rather take a beating than tilt the head, but certainly that would be a very viable solution. Just something I do not like to do, and as you well know, my list of things for which I would take a beating is quite long. But some alternates are to use a adjustable angle plate that can be set at different angles, a tilting vise, certainly not just a little drill press vise, but some of you might have milling vices that are capable of being tilted and have great rigidity. This is too small for the job. This would be okay, except how are you going to hold the work onto the plate? If you have a better idea or a better solution, put it in the comments, please. Okay, the way I'm going to hold it is simply use a couple of 1-inch parallels, and then I'm going to set that little 3-degree angle block right on top of it, like that. I put some layout die on here, and the taper only needs to be 1 1/4 long, so that's what that line is all about. And I'm just going to set it on the 3-degree, push it down real tightly, and I have to have it sticking up above the hardened jaws just enough so I don't strike the jaws. So I need to back that up a little bit, and by trial and error find the right position here. You can see I'm very close to the vise jaws, but yet we have to have some rigidity there, and it's not being taken down to a knife edge, but it's probably only about a 30-second thick right at the end. I'm finally ready to cut, and I misspoke. The black line is 1 1/2 inches. I want 1 1/2 inches of taper and about 1 1/4 inch or so of slot. 3/4 carbide end mill given to me by Wayne Fitch. The taper is 1.5 inches long. I've switched to a 1/4 end mill, and I've got a mark, you probably can't see it, so that I know how far to go. Here's the original two, and then the one I just completed. Could use some polishing, but I'm really never going to use it. So I'll use this along with one of the originals here. And again, these are just a hair too wide just to be proportional. They probably should be about 3/4. Because even the number 1 is a little wider, but it really doesn't matter for what we're doing here. And I put this little chuck back on the spindle here. Remember, that is a number 0 Jacob's taper. Maybe I can even take it off by hand. Let's see if I can. Yes. Because it's only been on there 5 minutes. And not all that hard, but you normally would tap it with a brass hammer up against an anvil or a vise, like shown in the other videos. So, that, ladies and gentlemen, is how you make Jacob's wedges to remove chucks that have a Jacob's taper. Hope you liked the video, and I'll see you next time. This is tubalcain.